Go, Matthew. Okay. Anyway. Hey, are you feeling pretty good about this? A little bit better? So let's go back. Sorry, who closed that door for a thing? Let's go back all the way back to the beginning, and we're doing nomenclature of compounds, aren't we? Inorganic compounds. And what I did is I divided them up into 5 types of compounds. Now, type 1. Type 1, can you, without looking, can you tell me what you're looking for? It's the easiest ones. They are what? Binary, and they're ionic, and they have, what is it? They always metals. Okay. I had somebody, I don't know why, yesterday, even though we said this about 5 times. Let's try it again. Who can I pick on? Riley. Tell me what the always metals are. Go.
That section.
What is that?
That section. 1A.
What do we call that?
1A.
What do you call it? 1A? What's it called? I had that last chapter. Alkali metals. And they always have what charge in a compound?
+1.
Yes. Keep going.
And then that section.
What's that section called? Remember, these are called groups or families.
Group 2. Oh, wait, no.
Group 2A,
Metals.
alkaline earth metals. Okay, and they always are what charge in a compound?
+2.
That's right. And then we have 3 more.
Gold.
What is that?
Gold.
No, gold is AU. It's like it though.
Silver.
Silver, that's what?
+1.
Yes,
Zinc.
yes,
+2.
yes.
Aluminum. Aluminum.
See, you said silver +1, zinc +2, and then you just said aluminum.
It's not aluminum.
No, remember you gave silver and you gave me a number. Then you gave me zinc and gave me a number.
+3.
+3, isn't it?
Yeah.
And so it goes 1, 2, 3. There you go. All right. Now, if you have a compound with those metals in there, you will never have to do the extra work of a Roman numeral. Get that? Because how many ways can you make sodium chloride? 1. How many ways can you make magnesium oxide? 1. So chemists don't need to tell you to use Roman numerals there. But what about type 2? Type 2 is, what is it? Type 2 is what? Binary. And what? Ionic. Not an always metal. That's a lot of them, isn't it? So for all the rest of the metals, you have to do a little extra work. And what does the Roman numeral stand for again? Charge on the metal. Yes. Okay, so let's review a little bit. Ready? Here's FeO. FeO, okay? FeO. Now, what is, I forgot, let's do this here. What about the nonmetals? These don't like to form compounds, so we're not going to talk about them. What are these going to be in a compound? They're going to be -1, -2, and -3. Got that? All right. So let's take a look at FeO. FeO, what is oxygen in a compound? -2. And all compounds have a net charge of 0. So if there's only one of you, you're -2, then you must be the iron that has a +2 charge, right? And the charge on the metal becomes the Roman numeral. So I name it the same way I did for type 1, except I have to put a Roman numeral set because how many different ways can you make iron oxide? There are 2. There are 2 ways to make iron oxide. This is iron 2 oxide. Now there's a tricky one here. This is a tricky one. Each oxygen is -2, and I have 3 of them. What's that give you? -6. Uh-oh. This whole thing better be +6, so 2 times what equals +6? So that means this iron, each iron is +3, and that becomes the Roman numeral iron. By the way, it's rust. Rust is iron 3 oxide, Fe2O3. Now, and notice that all binaries end in what? IDE. It's kind of like type 1, isn't it? Except we have to have a Roman numeral, do we? What do you think? Now, the other, unfortunately, the old system, before they figured out, Now, iron only had two kinds. Copper only had two kinds. Nickel only had two kinds. Vanadium, oh no. Vanadium has 2, 3, 4, 5. Oh no. The Ich and Us system's not going to work. That's when they started replacing it with the Roman numeral system. But the old system's still around. I just can't get rid of it. I guess it'd be nice to get rid of it, but they're not going to. So what is the old system of naming these type 2 compounds? It was the Ich and Us system, wasn't it? And so guess what? Here's iron 2, and here's iron 3. Which one is bigger?
3.
And the big, icky monster. That's my memory trick for you. 3 is bigger than 2, so, and I have to use the Latin word. What's the Latin word for iron? Ferrum. So how do you change ferrum into this ion? He's the big, icky monster. Ferric oxide. Now, once I use that system, I don't use Roman numerals with it, do I? You don't say ferric 2 to do that. Get that? Ferric already means iron 2, doesn't it? I'm sorry, iron 3, my fault. Now, what's this one going to be called? He's not the big icky, so he must be not ferric, but ferrous. So he's ferrous oxide. All right, let's look down here. Tin, and you don't have to memorize, I'll tell you. That tin comes in +2 and +4. Who's the big icky monster there?
Plus
4. Now, the Latin word is stannum. So another word for this, another name for this would be, besides tin 4 oxide, it'd be stannic, what? Oxide. Stannic oxide. Okay, and he's not the big icky monster, so what's his name? Stannous oxide. Oh, very good. Yes.
So like on the quiz, are you gonna give us the Latin name?
Yep. Matter of fact, tomorrow's quiz, I will give you, I'll even tell you iron comes in +2 and +3, and I'll say the Latin word's ferrum. And I'll tell you all that. And the quiz tomorrow, I'll tell you, I'll give you all the polyatomics. You don't have to have any of them memorized till next Wednesday.
On the test, but we have to know the Latin words?
No, actually, I'll give them to you on the test. What do you think about that? Huh? That's pretty good. All right. Now, when you go to type 3, it seems scary. But it's not. It's actually, it's kind of like type 1 and 2, except the second part of it is this weird looking thing that has many atoms in it. What do you call something that, here, I always ask this on the test, ready? What do you call a group of atoms that are bonded together whose net charge is 0? What do you call that? Compound. What do you call a bunch of atoms that are bonded together whose net charge is not 0? What is it? No, it is covalent bonding, but what do you call a group of elements that are bonded together, but their net charge is not 0? That's a good question. I haven't talked about stability.
Yeah.
But you can't call them a compound, so you have to call them a...
Ionic compounds.
No, they're not a compound because not net charge is 0. What kind of ion? Yes. What is it? I have to call it a polyatomic ion. Get it? Does that seem right to you? So you can't call it a compound because net charge is not 0. So you got to call it polyatomic ion. It's a bunch of atoms that together act like a single ion, like that. You'll see me today do this a lot. Here, sulfate. How many sulfates are there? Sulfates, SO4. SO4. How many? All right, so here we go. Let's pick one. Let's pick an easy one right here. And we see, I have some good news for you. If it's more than 2, if it's not binary, I have some good news for you. It contains a polyatomic ion. Good news number 2. Someone else has already named that polyatomic ion. Good news number 3. You will never change the name of a polyatomic ion. Wow, that's some good news, isn't it? So now, here's what we do, ready? We're going to go find that guy. Now, you can find him on the back of this sheet, or I happen to know your homework sheet, have him right there in front of you. Get that? So find NO3, and what's his name?
Nitrate.
And you know what? You'll never change that name, never. So, what are you going to call this? You won't believe how easy this is. Sodium nitrate. That's it? That's it? Yes? Let's do another one. How about this guy? It's got more than 2 elements. Look, potassium, sulfur, oxygen. It's got more than 2 elements, so it's got to have a polyatomic ion. Let's go find SO4. SO4. Sulfate. I found you. What are you going to call this guy? Don't you look at this, though? No. Of the 5 types I'm going to teach you, only one type do you ever look at the subscripts and name it. Do not do that. Now, this is just potassium sulfate. Look at this one, though. I'm going to trick you on this one. It's got more than, say, it's got iron, carbon, and oxygen, right? That means it has a polyatomic ion. Find it. Find CO3. Carbonate. Okay. Iron carbonate. Ooh, forgot something. I had to do a little extra work. Why do I have to do extra work on this one? It's not an always metal. What's the charge on carbonate? I don't have that memorized, so I gotta look it up. What is it? -2. Okay. So this whole thing, look at my fist. This whole thing is what? -2. The whole compound has to add up to what? So what is iron going to be? If this whole thing is -2, then what's that? +2, and that becomes the Roman numeral. And so that's not that bad. Iron 2 carbonate. Let's do the ick and us name. Iron comes in +2 and +3. The Latin word is ferrum. Is this the big icky or not? No, so what's another name for iron 2 carbonate? Ferrous carbonate. You guys can now name a couple thousand compounds now. I know you haven't memorized your polyatomics yet, but you will. You will. Okay. Do you see how knowing type 1 and type 2 came into play here? Even knowing the ick and us, see that? So type 3 is not this huge thing. It's actually not bad. Now, there's one thing I haven't done yet so far is I wrote out the formulas for you, but now what we're going to do here is write out, I'm gonna write out the name, and you come up with a formula. Let's try one. Let's try, I'm going to cover this up so you can't see it. Oh, hey, okay. Ready? Iron 2 hydroxide. Did you say iron 2? See? You said iron 2. Didn't I tell you it was iron 2? That Roman numeral is what? Into the charge on the metal? Okay. And hydroxide. And, hydroxide. Oh, I see you. What's hydroxide? Okay, now, OH. And what's the charge on that hydroxide? -1. So that, now, we have a problem here. Because that can't be a compound. It doesn't have a net charge of 0. So we've got to fix it. Pretend like this is just one atom there. Pretend it's like one ion, okay? How many of these -1 ions would you need? I need 2, right? Now, watch now. You cannot do this because that says you have 2 H's. I don't want 2 H's. I want 2 what? OH's. So, the only time, that's always a test question, when's the only time you need to use a parentheses when you write a formula? When you need more than one, fill in the blank. The only time I use parentheses in a formula is when I need more than one polyatomic ion. And I'm not being mean, but if you were to put a parentheses around this, I'd count it wrong because you didn't need more than one nitrate. You only use parentheses if you need more than one of the polyatomic ion, and I did. All right, let's do another one. Let's do, okay. Let's do some homework questions. How about that? Now, I didn't have to do this, and it was easy for me to do it, maybe not for you, but first of all, these are all type 3. These are all type 3, but I noticed that they used potassium and sodium and magnesium a lot, and those are always metals, aren't they? So I don't have to use Roman numerals for most of these, do I? but I went ahead and circled the ones that are kind of different. Why is number 1 different?
It's not always metal.
It's not always metal. So we're going to put copper, and I'm going to leave a space, and I look this SO4 up, and what is SO4?
Sulfate.
Sulfate. So I'm going to leave a space, but there you go. Now, how do I figure out the Roman numeral on this? What's the charge on this big thing called sulfate? What's the charge on sulfate? -2. Then that copper must be what? And that becomes the Roman numeral. What do you think about that? Now, I happen to know that the next one that is not an always metal is down here at number 43. All right, you want to do that one? See if you. So it's going to be copper. Leave a space. Ooh, what's that guy? What's that guy? What is it? Phosphate. Okay, now, a little tricky here. What's the charge on each phosphate? -3. Now, wait a minute, watch now. Each phosphate's -3, but how many phosphates do you have? 2. What's 2 times -3? That's -6. Well, this whole thing but here better be +6. So what's 3 times what gives you +6? So what's the charge on each copper? 2. Did I go too fast on that? You sure? Okay, do the next one by yourself then. Riley, even though they had to learn all 100 elements, there's really only going to be about probably 30 that I use all the time. So I bet you can pick up to 30 pretty quickly. I bet you already have some of them, don't you? Does this thing have more than 2 elements in it? Then it has to have a polyatomic ion, doesn't it? Can you find the polyatomic ion? Okay. We know it's nickel. Leave a space. Hydroxide. All right. What's the charge on OH? -1. And so therefore, what's the charge on nickel? +1. So what are we going to do here? Nickel 1 hydroxide. Ooh, ooh. Okay. Are you feeling a little better? Okay. All right. Now, one thing that I didn't mention to you is you eventually, tomorrow you're going to turn in an assignment, a small assignment. What is that small assignment? Okay, now, they're color-coded though, aren't they? Now, I don't want you to have to go out and say, Mom, Dad, we got to go to the store and find colored index cards. You don't. You can take a piece of blank paper and make your flashcards if you want. Are they for me or are they for you? I'm not going to use them. Who's going to use them? You are. Make them nice for you. Don't just say, oh, I got that done. Give me a grade. You can. Then do you want to use them? If they're ugly looking, make them look nice. Now, if you don't want to go out, don't go out and buy colored ones. Just get a marker. Get some kind of marker. And maybe if you like red, you could go like this, couldn't you? Look, that side's red, isn't it? So let's say that's red. I'm just pretending. There's a whole bunch of polyatomic ions with a -1 charge, right? Oh, I like red. I'm gonna make all my -1s red. And so what's gonna be on one side of the card? Like for example, NO3 -1. Now, every year, here's what people do, and they make a mistake. It's not capital N, little o. How do I know that? What's capital N, little o? That's nobelium. That's an element. What's capital N, big O? 3. See? It's not capital N, little o, is it? And also, if you don't put that charge there, it's not nitrate. Got that? So, it's red. You put this there, and on the back, you say what? There. Now, I'm going to help you a little bit here. And here's what I would do if I had to start memorizing 30 polyatomic ions. The first step is I put some little asterisks here. I call this the famous 8s. Okay, the famous 8s. Now, look at this guy here. Phosphate. Everybody get that? Now, phosphate has phosphorus in it, doesn't it? I wish all the 8s ended in O4, but they don't. I wish, but they don't. I'm sorry. Let's go over here and look at this guy here. He's a famous 8. What's he? Hey, at least you're SO4. What's that called? Not phosphate, but sulfate. Yeah, I kind of like that. And look at this guy. Oh, you're not O4. That's okay. Sorry. But what's CO3? Carbonate. It has carbon in it, doesn't it? All right. We'll come back to that guy later. Well, let's do this one. Chromate. Ready? Chromate has chromium in it. CR. And it's O4. Hey, I like you. I don't like you because you should have been O4. Right? All right. Let's go over here now. How about this guy? Oh, you're not O4. Oh, well. Nitrate. It has nitrogen in it, doesn't it? Let's go down here. Chlorate has what in it? Every year, I have people turn in a flashcard, and it says they'll have CiO3. What is that? What is CI?
Carbon iodide.
What? It can't be CI, is it? What is it?
CL.
ClO3, isn't it? Doesn't chlorate have chlorine in it? Okay. Now, and then one, which is so weird, that even when I went to college, no one made me memorize these. Sorry, I'm making you memorize them. I never had to memorize them, but I know that was a weakness of mine when I went to chemistry. That was a weakness. I had a girl, she was like one of the top students in the class a few years ago. She went to Chapel Hill. And she's at Chapel Hill. These are some very top students, okay? And she's taking chemistry. And the chemistry professor walks in and says, you have to learn 20 polyatomic ions and memorize them. And the whole, it's a Chapel Hill. And like 200 kids, oh, they were groaning. Oh, no. At Chapel Hill, they're groaning about memorizing 20 polyatomic ions. Well, she had to learn 35. She told her mom, tell Mr. Feeney, thanks. And we see, so here's at Chapel Hill, and some of the teachers don't make you memorize it, and I think you should. Anyway, so this one right here is a weird one, and it doesn't even remind me of acetate. It's got carbon, hydrogen, oxygen, but I'll show you how, when I went to college, I had to make myself give them a memory trick. So what I did was I went CHO, now watch now, CHO, now watch, 2, 3, 2, 2, 3, 2. Okay, anyway, that sounds dumb, and I don't say it out loud when I'm doing it. When I'm writing acetate, in my mind I go CHO, and I go, see, I have it. And I've always memorized it from that. So anyway, if you'll memorize the famous 8s, that's a great, great start. If you tell yourself by Monday, can I have the famous 8s memorized? You won't have to have any of them memorized for tomorrow's quiz. You got that? None of them. I'll give them to you. You all right? Okay. Another way to help me memorize this is that, first of all, how many of them are +1s? And when you do your color coding, you're going to have a whole bunch of them that have that color, not so many with this color, only a couple with that color, and only one of them with that color. When you color code it, it's going to remind you, most of them are -1, aren't they? How many of them are -3? There's only 2. There's only 2. Okay, so you know a little trick, okay? Let's assume on Monday you have the famous 8s memorized. What's phosphate? On Monday you say PO4 -3. Well, then what's phosphite? Take away an oxygen. Phosphate was PO4 -3. What's phosphite? PO3 -3. Look here. Sulfate is what? On Monday you'll say sulfate's SO4 -2. Take away an oxygen, what do you get? Not sulfate, but sulfite, and it's not SO4, but SO3. Same charge though, -2. Huh, look at that. And then come over here, how about nitrate? Nitrate, on Monday you'll say, nitrate's NO3, -1. Well, take away an oxygen, what do you get? Not nitrate, but nitrite. Not NO3, but NO. Ooh, I like this. And if you memorize chlorate by Monday, I'll bet you know chlorite. If chlorate's ClO3, what's chloride? ClO2, same charge. Ooh, all right. I can do that. All right. You okay on that? That's just giving you a little hint. And by the way, how many are on +1? There's only one of them. Really? There's only one. Ammonium. Let's go back to your homework sheet. There you go. I don't know why this author, he loves ammonium, I guess. He loves ammonium. But isn't this weird? Look, is that more than 2 elements? Then we have to look for a polyatomic ion, and I bet you probably found this guy, didn't you? But what's this? Whoa! This is made of 2 polyatomic ions. What's the only one that's positively charged? What's the only one that's going to be written first? Ammonium. So say it. Just say it. Tell me a name here. Ready? Ammonium. Hydroxide. Ooh. That's it? Yes. Yes. Really? When I walked in today, how many of you thought you could name NH4OH? None of you. All right. What about this guy? What do you think? Ammonium. Say it. Ammonium what? Chloride. How about down here? Look at that guy. 32. Ammonium. And even though it's not really binary, it acts like binary because you got this one ion and another ion, don't you? So it's ammonium fluoride. How about here? This guy loved ammonium. Ammonium iodide. All right. So, here we go. I'm gonna go around the room, and we're gonna do this page here. And if you pay attention, you'll probably have the entire page finished when we get done here. Let me see. I'll watch my time. I'm gonna go around the room a couple times. We have until 10:50. We can do it. All right. Are you ready, Sawyer? Are you ready? In your mind, think about your mind. Are you thinking of this? What are you thinking about this? What comes in your mind when you see this? Oh my gosh! Or what do you think?
I was thinking,
How many elements?
yeah, that's what I was thinking.
How many? Here, I'll give you a clue.
2.
Oh,
Or no, I mean 3.
oh, it's more than 2, so it must have a what in it?
Polyatomic.
Okay, so you got your other sheet ready? Got your other sheet handy? So I'm gonna put the polyatomic ion over here. Put them over here. All right, have you found that one already?
Yeah.
All right, ready? What you got?
Calcium. And then a space.
Okay.
And then carbonate.
Now tell everybody why you need a space.
Because gotta put the Roman numeral.
Why?
Why?
Yeah. Every compound have a Roman numeral?
No.
Now, how do you know?
Because it's polyatomic.
Huh?
Polyatomic.
No, I never taught that. Never taught that. I never taught that polyatomic ions in Roman numerals. Matter of fact, I always said the Roman numeral. What does the Roman numeral stand for? Charge of what? What element? It's always a charge on the what? The metal. But I believe calcium is what? Oh, that's an always metal. Oh, you made yourself work too hard. You're working too hard. Now, I know your neck might get a little sore looking at the periodic table, all right? But did you know that calcium is an always metal? Ask Riley. Ask him if it's one of the always metals.
Is it always metal? Yeah.
How do you know? It's in group 2A, isn't it? Isn't that right? All right, so we don't need a Roman numeral there. So you made too much work, okay? Next. What do you think about this one? What goes on your head here?
It's type 1
It is.
because it's an always metal.
And it's binary, isn't it?
Yeah, it's a binary, but it's an always metal.
Go ahead.
A non-metal. It's potassium chloride.
Yes. All binaries end in what?
I.
IDE, yes. All right, here we go.
It's iron, and iron isn't an always metal, so it's in space.
And look, it had how many elements in it?
It has 3 in it,
Ooh.
so it's a polyatomic ion.
What is that name?
It's sulfate,
Okay.
and charge of -2.
Nice.
So iron has to have a positive charge of 2.
Yes.
So you're gonna have a Roman numeral 2 right beside that.
Huh. And you are so lucky you get to give me the other name. Now I'm going to tell you that iron comes in two types, +2 and +3. And the Latin word is ferrum. What's the other name for iron 2 sulfate?
It would be ferrous sulfate because 2
Say it again.
ferrous sulfate.
Is he the big icky monster?
It's smaller than 2. It's smaller than 3.
He's not big. Here's big. So what is it?
Ferrous.
Ferrous sulfate. All right, you ready, Lauren? Oh, by the way, did you notice that she was the first person that had to figure out charges, didn't he? If it's an always metal, what is it like? What do you say here? Calcium carbonate, potassium chloride. What? Oh, wait, got extra time here. Got to spend some extra time, don't I? All right, next. Ready?
Lithium is an always metal, so you don't have to do this page.
Okay.
It'll be lithium bromide.
Very good. All right. Come on, you guys are good. Go.
It's magnesium. It's charged +2, so it's magnesium.
Say it real loud.
Magnesium and charge +2, so it's magnesium
Oh,
2.
you're making too much work for yourself. It's an always metal, right?
Oh, sorry, never mind. It's just magnesium chloride.
That's it. Yeah, see it? See, if you recognize an always metal, it's not no extra work, is it? It's easy. Next one. Oh, who's ready for this one? Leroy.
I think it's iron, then iron chloride.
All right. Now, you're in pretty good shape, except is iron an always metal?
No.
So we got extra work, don't we?
Yes.
What's the charge of chlorine in a compound?
-1.
And how many do you have?
3.
That's -3.
So it's iron 3.
Yes. Iron 3 chloride. Now, you're so lucky, Leroy, you got to give me another answer. Iron comes in two types, +2 and +3. And the Latin word is ferrum. What's another word for iron 3 chloride?
Ferric.
Yes. You guys are doing great. Really. Okay, Libby, ready?
Zinc,
Say it real loud.
zinc phosphate.
What? No Roman numerals? Huh? No Roman numerals? Libby, tell everybody what always metals are.
Alkali metals,
Group 1A is always +1. Group 2A is what?
alkaline metals.
And they're always what?
+2,
And what's this guy?
+1, +2, +3.
So is zinc an always metal? So no Roman numerals, all right? All right, ready? Next. Ooh, look at this one. The good news, there's only one polyatomic that's ever written first. It's the only one that's plus charged. What is it? Yes?
Nitrate,
Ammonium, what is it?
nitrate.
Nitrate. You never change the name of a polyatomic ion, so it's nitrate, isn't it? That's it. Next, Riley.
Aluminum hydroxide.
Wait a minute, Riley. You forgot the Roman numeral, didn't you? Huh? Why not? Yes, very good. All right, Dave.
Copper space acetate.
Acetate,
Uh,
And what's the charge on? Ooh, look at that big old guy. Ooh, he's big, but what's his charge?
That'd have to be -1.
So,
Copper 1 acetate.
yes. Now, I will tell you that copper comes in +1 and +2. The Latin word is cuprum.
Cuprous. Acetate.
Try it again.
Cuprous acetate.
Cuprous. Yes.
Said cuprous.
Is that what you said the first time?
Yeah.
Oh, sorry. All right, next. No Roman numeral?
Yes.
It's nice to look at the periodic table, but it's not gonna help you on this one. The periodic table won't help you on this one. What's the charge? Oh, you say sulfate? You know, what's interesting is sulfate's SO4, but did you say sulfate or sulfite?
Is it sulfite?
Ah, it is sulfite. Okay, so Roman numeral or not?
Yes.
What's the charge on sulfite?
-2.
Yes. So,
+2.
yes.
So lead, Roman numeral 2.
Oh, you're so lucky. You got to give me another name. Now, lead comes in 2 and 4. The Latin word is plumbum. And
Plumbus.
plumbus, Plumbus. Plumbus what?
Sulfite.
All right, you never change the name of polyatomic ion. All right, we'll do 2 more of these, then we'll switch gears a little bit. All right, Sally.
Sodium chlorate.
Say it again.
Sodium chlorate.
Chlorate. What about your Roman numeral?
Blood.
No, you don't want to put a Roman numeral. Why do you not put a Roman numeral? It's an always metal. All right, now, even though I think you're feeling better about this, aren't you? You know what your brain also has to be able to do? Uh-oh. What page is that on? You have to be able to go backwards, don't we? Oh, here we go. Ooh. Find this page here. So we have to be able to go backwards too. All right. Sawyer, are you ready?
Yeah.
Okay, now, the only polyatomic that's ever written first, because it's positive, is ammonium. Can you find it?
It's NH, right?
NH what?
NH4.
Yes, and has what charge?
A positive 1 charge.
Plus 1. And phosphate. Find that one.
It's PO4.
What charge?
-3.
Okay, now, here's where you have to be careful, okay? Here's ammonium, and here's phosphate. But phosphate's charge is -3, and you're only +1. That's not going to work out. Do I need more ammoniums, or do I need more phosphates?
More phosphate.
He's already ahead.
I mean, no more ammonium.
So how many total ammoniums would you like to have? I'll give you a clue, okay? If I have only 1 of these, it's not going to work. What if I give you 2?
I need 3.
That'd be +2. Oh, how many?
3.
Now, do I put a 43 here? What's the only time you use a parentheses in a formula?
I'll write it down.
When you need what? When you need more than 1 what?
Polyatomic.
Yes. Now, look. If each ammonia is +1, you have 3 of them. That'd be +3. Nice 3. Yeah, we're there. All right, Ryan.
So it's Fe
What charge?
+2
How'd you know that?
because it's the Roman numeral.
Yeah, I told you. Iron 2 is iron +2, isn't it?
And oxide is O3.
How'd you know that?
Just because I remembered it because the I.
Look up here.
Um,
What's the charge of oxygen in a compound?
it's -3.
How much?
-3. 2.
Is that right? Remember, these guys, they're not going to form compounds, so
Yeah.
leave them like this: -1, -2, -3. So, what do you think? Are you done or not?
I'm done.
I'm done. She's done. Final answer? FeO. See? Final answer. All right, ready? Go.
So it's iron and it's going to be Fe +3
How'd you know that?
because of the Roman numeral.
Yes.
And then it's oxygen and the charge is -2.
Uh-oh. We got a problem here.
You need 2 irons and
All right, the smallest number they both go into is 6. So what times 3 is 6?
2.
What? What do you think about that? I'm looking at your faces. Your faces have to tell me what's going on. All right. You can't do this one yet, so we're going to skip that one, okay? This is another type. It's actually called type 5. We're not doing that right now. I don't know why the author put that in there. Let's go down to number 5. You were all ready for number 4, weren't you? Sorry. Do number 5. Don't even look at number 4. Don't even do it.
NBCA.
Okay. Now, what's the what's the charge of calcium in a compound?
+2.
Yes. What about chlorine in a compound? All right. That's not going to work. What are you going to do?
ABCACO2.
Yes. I need 2 chlorines, don't I? All right. Very good. Next.
It's potassium nitrate, so it's KNO2.
What's nitrate?
3. Oh,
No, 3.
What's nitrate?
oh, it's NO3.
Okay. And what's the charge on nitrate?
Oh, just 1.
-1, isn't it?
Negative 1.
What's the charge on potassium?
Positive 1.
What are you gonna do now?
Leave it.
Leave it. I like that. Leave it. Very good. Next.
Magnesium's Mg, and then hydroxide is.
What's magnesium?
+2.
What? How do you say magnesium? How do you write it? Mn or Mg?
Mg.
What's the charge on magnesium?
+2.
Yes. Hydroxide.
Hydroxide is OH -1.
Yes. Ooh, he's hot. Come on now.
You have to put OH in parentheses,
Yes.
and then put a 2.
Yes. Woo. You guys are doing very well. Very well. All right, Libby.
NH4.
Wait, are you doing this one?
Aluminum, sorry, that's it.
Oh, aluminum's Al, isn't it? Okay. Okay.
And then sulfate.
What's the charge of aluminum in a compound?
Plus.
Riley knows. Ask Riley.
+3.
What?
Plus 3.
+3.
So,
Sulfate.
SO4.
What's the charge?
2.
What kind of 2?
Negative.
-2, right? Oh, we got a problem here. We got a problem here. This is the last one, I think.
You need one more sulfate.
Oh. Oh yeah, we gotta go. All right, ready?
One more sulfate.
And how do you? That means a total of how many though?
2.
What's the smallest number in 3 and 2 go into?
6.
What times 3 is 6?
3.
And how many sulfates do I need? That's the trickiest one, okay? All right, great job today.